So good morning. This is Manoj Kumar, Assistant Professor from Kalpataru Institute of Technology. So handling data structure classes. So currently we are discussing in module one, last but one topic. Okay. So module one, we are in the last topic. So what is the last but one? You have another one more concept. So in today's class, we are going with two concepts. One is sparse matrix. The other one is transposing the sparse matrix. Okay, so what is sparse matrix and what is the transpose of it? So now we shall see in this particular class. So you have gone with two types of matrix, sorry, two types of an array, one dimensional array and two dimensional array. So in the previous classes, we have gone with uh, what is point use of pointer in 2D array. Okay, so how to get the address of the 2D array in Linux operating system, how to get the address of the 2D array in Windows operating system using Turbo C3. So everything we have discussed in that particular classes. In today's class, we will go with a new concept called as sparse matrix. So sparse matrix means it is a type of two-dimensional array. Okay. So how the matrix means, matrix will be consisting of rows and columns. In today's class, we will go with a new matrix called as sparse matrix. So when you call a matrix as sparse, so that we have to go with a definition. Okay. So see the definition of the sparse matrix. The sparse matrix as a relative number of elements or zero. So what you tell it, what is a sparse matrix? That has a relative number of elements are zero. So any two-dimensional array or a matrix whose number of elements, if two-thirds of the elements are zero, then we call it as sparse matrix. Okay, so it is representing a sparse matrix. So representing a sparse matrix takes substantial amount of space with no use. So can you tell, because here most of the elements in the sparse matrix are what? No elements will be there. It will be taken as zero. So for that particular purpose, now you are representing a sparse matrix. So inside the sparse matrix, you are having all the elements as zero. So there is no use. So that causes amount of space with no use. Okay. So it can be represented by triplets. So sparse matrix can be represented by triplets. That means whatever the matrix is there. So in most of the elements are zero. So now you can reduce the size of the matrix. Okay. So that size of the matrix should be reduced so that amount of space should be reduced because there are most of the elements are zero. So representing a sparse matrix with large amount of space is of no use. So as it is of no use, now you have to reduce the zero elements. So it is represented by triplets. So triplets with a maximum column of 3 and okay. So this is the sparse matrix we have taken. So see in this sparse matrix, how many rows are there? Rows 1 2 3 4 5, 5 rows. How many columns are there? 1 2 3 4 5 6, 6 columns. So 5 cross 6, how many elements will be there? 30 elements will be there. Okay, 1 2 3 4 5, 5 rows into 6 columns is equal to 30 elements. So all in all the 30 elements, how many values you are having? 1 2 3 4 5 6 values are there. Out of 30 values, you are having 6 values. Remaining 24 are 0. So now you have to represent the non-zero elements. Remove all the zero elements and represent non-zero elements. So that is the output you are taking. What is the output? The sparse matrix will be represented with elements. So that we consider it as triplet. So triplet means 3. So triplet will consist of 3 columns. One is row, the other one is column, other one is value. So first you give the total count. So first in triplet, what you are going to have, it is the total count. How many rows are there? 1 2 3 4 5, 5 rows. How many columns are there? 6, 6 columns. How many values are there? Just count the values. 1 2 3 4 5 6. So 6 values are there. Okay. So now you have to represent where these values are. How many values are there? 6 values are there. So where these values are, first value is 9. So where is this? So it is in 0th row and 0, 1, 2, 3, 4th column. So it is in 0th row, 4th column, you are having a value 9. So similarly, you come for 8. So it is in first row. First row, this one is 0th column, this one is first column. So first row, first column, you have value 8. Similarly, you come for next is 4. So 4 is at row 2, column 0. Similarly, 2 is at row 2, column 3. Similarly, 5 is at, it is at row 3, column 5. Similarly, 2 is at row 4, column 2. So this is the representation of sparse matrix in triplets. So why you are going to convert a sparse matrix into triplet? Because most of the elements in the sparse matrix will be 0 and it will take much space. So in order to, as it is taking much space, so we are reducing the space in the form of triplet. Okay, so what the sparse matrix will tell, it is represented by triplets with a maximum column of 3 and each row corresponding row number. So column number of non-zero elements and non-zero element itself. So you are going with 9. What is the first value? 9. It is a non-zero. Next you are going with 8. It is a non-zero. Next, we are going with 4. All the non-zero elements we have taken, but not 0. So you got the concept, understood this concept? Understood sparse matrix, right? Any doubts you are having in sparse matrix? Now, come for the question. So, when will a matrix is said to be sparse? So, tell me the reason. So, when will the matrix is said to be sparse matrix? So, chat in the group chat. So I want the answer from everyone. There are nearly 40 participants. Kindly respond. So very, very important concept from exam point of view. That's why. Matrix is said to be sparse matrix. Yes, tell me. Zero elements are present, then it is sparse. Okay, good. Then only one reply. The element is 0. Okay, good. Next. Okay. Okay, I got you people got understood, right? So now you come for the program on that. So this is the program that I am going to take it for the sparse matrix to compact matrix. So keep in your mind what is sparse matrix means. The first one, what you take the in terms of rows and columns, that we take it as sparse matrix. Okay, so that sparse matrix is to be converted into compact matrix. So compact means it has been reduced. So compact matrix, you take it as So compact matrix, you take it in terms of triplet. So triplet table is called as a compact matrix. Okay. So now you come for this particular program. Okay. So come for this particular program. Now you have, what is the thing I am doing is I will enter the values for the sparse matrix, and that is to be converted into triplets. Understood? So what is to be done? It should be converted into triplets. So for that, you start from the first line. First is including the library header files, that is stdio.h and stdlib.h. Now I define R, that is row. So how many rows you are taking? 6 rows. How many columns you are taking? So I am taking 5 columns. So 6 cross 5, same. Here you are having how many rows? 5 rows with 6 columns. But here I am taking it as 6 rows with 5 columns. Okay. So come for the main function. So what is the array name? It is SM. SM means sparse matrix of number of rows, number of columns. Next I go with the index variable. First one is X for number of rows. Next is Y for number of columns. And next you go with a Z, that is value. Row, column with a value. Okay. So row, column and value and total number of elements. So total number of elements we go with dot nz. Total number of z means z is value. Okay. How many non-zero values are there that represents z? Okay. So now you come with a start. Okay. So first you see you are taking a pointer. Okay. So pointer, what is a? It is a pointer variable of address. How many is size? So you are having 3. So size is 3 means it is going to take 3 address. So first you go with x is equal to 0, x less than r, x plus plus. Next you go with y is equal to 0, y less than c, y plus plus. Now you enter each and every value for x and y. Okay, so enter the data for row %d, column %d, comma x, comma y. Enter the data for row 0, column 0, row 0, column 1, row 0, column 2, like that it is going to take. Okay, so that is similar to this one. So first you are going with a first row means row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4, row 0, column 5. So like that it is going to take. So that is the, we are reading the values. Okay, so now if, now you come for the condition. So when you tell there is a value, okay, so if sm of x comma y is not equal to 0, so not, if it are not equal to 0 means you add it to your value. So for that I am going to take dot nz plus plus. So dot of nz plus plus means total number. So where you get the total number? So see here you are having values. So values you have given 6. So 6 means that will be the total number here. Total nz plus plus means total of non-zero elements. So which are the non-zero elements that we will get the count using this one. Okay. So next you are going for a allocation. So you have come across the word malloc, right? So what the malloc will do, it will allocate a specified bytes. Okay, specified bytes of memory. So what is the total number? So total number depends on how many values? 1 value, 2, 3, 4, 5, 6 values. So total is 6 plus 1, that is 7, 7 star 5. So 7 star 6. So it is 42 bytes of memory is allocated. So keep in your mind, for our example, go for the output. So in output here you see how many values are there? 1, 2, 3, 4, 5, 6 values. So it is 6. Okay. So 6 plus, sorry, it is 6 plus 1. 6 plus 1. So you put it in brackets. So total number of values is nothing but what you see in the yellow. So there you count the total number, it is 6. So 6 star 1. So 6 plus 1 star 3 star 2. So this will result in 6 plus 1 is 7. 7 star 3 star 2, 6. 7 star 6, 7 6 are 42. Okay, so 42 bytes So 42 bytes of memory is being allocated. Okay, now you have to go with a matrix. So for going with a matrix, now you see first triplet means first row you will be getting row. So that row we consider it as A of 0, 0. Next for column you go with A of 0, 1 is equal to column. Next A of 0, 2 is equal to total. So this is the thing you are giving for the triplet. So triplet will consist of three columns. One is row, the other one is column, the other one is value. So A of 0, 0 is equal to row, A of 0, 1 is equal to column, A of 0, 2 is equal to total of NZ. Okay, so now what should be done? So now you have to, if not equal to 0, now you have to place that value. Okay, so if it is a non-zero element, so start reading the elements. So for x is equal to 0, x less than r, y is equal to 0, y less than c. If it is not equal to 0, so place the first value in z of 0, y in z of 1, and value in z of 2. What is this z? It is a triplet. Okay, so triplet form. So this one now I am going. So first one is row, second one is column, second one is, third one is value. So here you see f of z0 is equal to x, means x is nothing but what? Row. F of z1 is equal to y, that is equal to column. F of z2 is equal to s sum of xy, that is equal to value. Understood? So now you are going to, after you place all these things, now you are going to print the sparse matrix. So printing the sparse matrix, so it is not a triplet. We are printing the sparse matrix. Okay. So printing the sparse matrix, no change. Just print the statement what you have. X is equal to 0, x less than r, y is equal to 0, y less than c. Print % sum of xy. So what you given here, so what you give here, the same thing will be printed here. Okay, so now you come for, after printing the sparse matrix, now you print the concised array. So concised array means you have reduced. So what is the reduced one? It is the triplet. So triplet, how to print the value? So it is x is equal to 0. X should be less than total number of elements. Okay, so y, what is x? It is row. Okay, so total number of elements you have to vary, but you go with the y. What is y? It is a column. So column, how many columns you should get in the triplet? It is 3 columns, one for row, one for column. So 3 columns you should get. So that 3 columns is here. So see here, y is equal to 0, y less than 3. So y is equal to 0, y less than 3 means 3 columns means one for row, one for column, the other one is value. Okay, so now you are printing %d of xy. So you are printing printf %d of xy. That will print the value. Okay, so come for the output here. First first you see, enter the row %d, column %d. So that will take 6 cross 5. So this part will go with inserting all the values. Okay, next you come for the sparse matrix. So printing the sparse matrix. So this is the code. So for this output, so what I have given in the rate, that is the code to get the sparse matrix. Okay, so sparse matrix converted to compact matrix is, this code will generate you a sparse matrix for that. Understood? So so got this program? Kindly respond. Next, you come for transposing sparse matrix in slow or faster method. Okay, so you have come across this one, right? How to transpose the sparse matrix into triplet. So I have already told you. So first row in the triplet will tell you how many rows are there? How many rows you see? 5 rows, 6 columns. Total number of values are 1, 2, 3, 4, 5, 6. Okay. Now you represent each and every one. 0th row, 4th column 9. First row, first column 8. Second row, 0th column 4. Second row, third column 2. So third row, fifth column 5, and fourth row, second column is 2. Okay. So now for that, so now you have to convert the transpose the matrix. So transposing by slower method, and you can go with a faster method also. So slower method means, so what you do for the transpose, you are going to shift all the row elements with the column elements. So that is called as a transpose. So first row, what you are having, 0 0 0 0 9 0. So first row is been replaced to first column, second row is in second column, third row is in third column, and so on. But when you come for triplets, now you see, so transposing through triplets is somewhat different. It's not difficult, it is different. So first you see, so coming for the triplets, so come for the triplets, for just interchange the first one. So column goes left and row comes right. So that's why we are telling column which is at 6 will come to the first row, and this row what you are having 5 will go there. Whereas the value 6 will remain same. Only rows and columns are shifted here. Understood? So come for the remaining part. So remaining part triplet, you have to go with this particular only. So go here. So it after you change this one. So 0th row, which is the column, 0th row, this one is second column. 0th row, second column, you are having value 4. So that is 0, 2, 4. 0th row, second column, you are having value 4. So next you come for, next is 8. That is first row, first column, you are having 8. So first row, first column is 8. Next you go with us. Second row, so second row you are having, so second row, fourth column, you have value 2. So similarly, third row, second column, you have value 2. And fourth row, 0th column, you have value 9. And fifth row, third column, you are having value 5. So this is the transposing the sparse matrix. So how you transpose the sparse matrix? So first is total, you shift the columns and rows, that you will get then this particular term. Next, you go with this particular slower pattern to get the values. Okay, so from slower method, you get all the values. From the faster method, you get the values, transpose of the values. So, so you have got the transpose of the sparse matrix. Have you understood? Want or want me to tell again? Have you understood the transpose? Or want me to tell again? Okay. Okay, pa. I will be telling again. Now you see. So transposing the sparse matrix through slow as well as faster medium. So first take the sparse matrix. So their rows and columns will be given. Okay. So come first. This one I think you have got the triplet form. Now go with a slower pattern. Slower pattern means where we replace. So slower pattern, we are going to replace the row with a column. So there you are going to, so there you are going to replace the row with a column. So first row, what you are having? So 4 zeros, 9 0. So it is 0 0 0 0 9 0. Rows becomes column elements. Okay. So now you can easily transpose the sparse matrix, but how you transpose a triplet. So transposing the triplet, so you should go with a faster method as well as slower method. So faster method means, so first replace the column in place of row and row in place of column. So column will go, column value is 6. So it will come in row place, and row value is 5. It will go with a column place. Okay. So come for the remaining part. So only the first triplet, what you have, the total number of rows, total number of columns, that can be replaced using faster method. For remaining all the values, you should follow the slow method. So slow method means, so take the sparse matrix. So that is 0th row, second column, you go with 4. So first row, first column is 8. Second row, fourth column is 2. Third column, third row, second column is 2. So you can get the triple transpose of the triplet only by the slower method. Understood? So now you come for the program of that particular transposing the sparse matrix. Okay. So first we have taken. So we are taking in the form of the functions. So first function is for reading the sparse, second for printing the sparse, and third one is for transpose. Next you come up with a main function. So start with a main function. So first we take the matrix. Okay. So that is trip one. Trip one is the matrix, that is the input matrix. So what is the another matrix we have taken? It is the output matrix, that is trip two. So what you get the transpose, that will be in trip 2 matrix. Okay. So total number of rows and columns you have to enter it here. Okay. So now initially trip 1, you are starting with trip 1. So input matrix is trip 1 and output matrix is trip 2. So trip 1 of 0, 0 means it is equal to total number of rows, total number of columns. Next we call with each and every function. First one is read sparse, second print, third transpose. So once you perform the transpose, you are again going for the printing the matrix. Okay. So read sparse trip 1, print sparse trip 1. This is the input matrix. Okay. So now you are transposing trip 1 into trip 2. So transposed matrix is trip 2. Now you are going to print that particular trip 2 matrix. So start from the read sparse matrix. So read the sparse matrix means read all the non-zero elements. Okay, so how to read? So see here, I've given printf, enter the total number of non-zero elements. So non-zero elements, we take it as t. Okay, so you have to read each and every value. For that, you can start with 0 or you can start with 1. Okay, so enter the triplet value. So triplet will take how many values? One is row, the other one is column, the other one is value. So totally 3 values, percent %d, percent %d, percent %d. Trip 1 of x0, that is x with 0 means row. Trip of x1, that is column. So trip of x2, that is for value. Okay. So if trip of x0 is greater than or equal to 3, wrong row. Okay. So this is the values. So how many values the triplet will take? Row, column, value. So row is strip of x0, column is strip of x1, value is strip of x2. Okay. So next, that is for reading the sparse matrix in the form of triplet. So print the matrix. So print means, so total number of values are 3. So what are the values? Row, column, value. So you are going to print all the values. Same thing, x0, x1, trip of x2. Okay. So what you are reading here, the same thing you are printing here. So that is for print sparse. Now you come for the transpose. So what the transpose? It will take 2 parameters. One is for input sparse matrix. The other one is output sparse matrix. So input is trip of x00 is equal to trip. So what you have in trip 1 should be in trip 2. So trip 1 column. So see here, trip 1 of 01. 01 means it is a column. So it has been moved to trip 2 of 00. That means it is at 0th row. So column what you are having, it has been moved to row. Similarly, row what you are having, it is moved to column. So these are the two lines used for moving the rows and columns. So first one is for moving the trip one column to row, and second one is moving the row to column. So similarly, trip 2 of 02 is equal to trip 1 of 02. This can be given or may not be given also. Okay. So now like that. So initially, this is the logic. So this is for one row you have done. Suppose if you want it for all the rows, if you want it for all the rows, then you have to go with this particular condition. So move all the row elements. So and move all the column elements. So this is the program used for calculating the transpose of the sparse matrix. Okay. So kindly understand. So these are the only the basic logic. So this is the, here comes your logic. So this is the logic for the first row, first column. So if the number of rows and columns are more, then you have to go with the number of rows are more, then we go with a for loop. Okay. So this is the logic why you are going with a for loop. So it is for, so finding the transpose for remaining rows. Understood? So this is for transpose to for remaining rows. So this is the logic for transpose of first row. So first row is been done here. So remaining all the rows you are going with this particular for loop contents. So this for loop contents is used to move the elements. Okay. I hope you got understood. Just you go through this three lines, the same thing is here. Okay. So in place of 0, you are having in terms of Z. In terms of 0, you are having in terms of Y. That is the only difference you are having. So once you first you read the sparse matrix, so print the sparse matrix. Then after transpose, what will be the sparse matrix that I will be showing in this particular output screen. Okay. So first leave the first one. So enter the triplet, 7 rows, 5 columns, 2 values. Okay. 7, 5, 2. Okay. So all these values are here. So after transposing, so now you see here, I will tell only this one. So here row is 7, that will come in column place. So column is 6, that will come in row place. So remaining, you have to go with this particular program. I hope understood. So 2 by third is equal to 0 means almost all elements in sparse matrix is 0. Okay. So I hope you understood this particular program, the sparse matrix and transposing the sparse matrix. Okay. So this particular thing is been shared. You can go through my YouTube channel also. Okay. Okay. Thank you.